All right, ladies and gentlemen, good morning, good afternoon, whatever it is for you. It is Saturday night for me recording this lesson because I have a jury duty on Monday. Yay! I do my civic duty. I can tell them, hey, I'm a junior high teacher. I know people are lying, so I can tell if they're guilty or not guilty. I don't know if they'll believe that. But we're going to try our best. I don't have my best microphone here, borrowed one of my kids. There might be a cricket in the background. But again, we're going to do the best that we can with the technology that we have right now. All right, so we're going to look at scientific notation. Scientific notation is going to be using our exponent rules that we just talked about right before spring break. But before you can actually use those rules, you need to be able to write a number in scientific notation, given a standard form like a normal number problem, or you need to go backwards and write a standard form number given a scientific notation number. So let's see how we do that. The first part you need to know about the scientific notation, it is primarily used for really large or really, really small, like almost microscopic numbers. If you think about it, using like a telescope to see into space, or if you use a microscope to see something really, really small, those are the size of numbers that we're talking about, not your normal everyday numbers. It says a base of 10. Now, the one thing that's really good about this is the base of 10 makes it pretty easy with our exponents to be combined, work with, and so on. So, for example, if you got a standard form number presented to you as 50 million, we want to be able to write it again in scientific notation. Scientific notation is going to start with a number that is between 1 and 9.99999. So in other words, if you have a problem, or if you have an answer more like it, that has a number that starts with 0 point, or even like 10 point, 11 point, 12 point, that is an incorrect answer for scientific notation. So you need to be able to identify where the decimal point is, obviously at the end, and we're going to go ahead and practice moving our decimals. As you move it, you're really just going to count. Now, we know that that was 3 zeros right there. So some students, they're able to just look at it and say, oh, a group of 3, another group of 3, so that's 6, and one more is 7. So that's where I'm going to stop. Because if I move it one more time, then that means it would start with 0 point. If I stopped too early, like here, that would be a 50 point, and we don't want that. We want it somewhere between 1 and 9.9. So if I stop there, it would actually be a 5 point something. I moved it a total of 7 times, and notice how it's a positive 7 because we have a really large number. Large numbers are going to be dealing with a positive exponent. Small numbers will deal with a negative exponent. And let's see here. So this is how it's going to look, 5.0. Now some people may say, Mr. Murray, do I really need that 0.0? We're going to say yes. You're going to practice using that correct placement of the decimal point. And then again, we moved it 7 times, positive, big number, positive exponent. It has to be greater than 1, could be equal to it, but it's got to be less than 10. So I always like telling my students it's somewhere between 1 and 9.99999 and so on. And often that is called the coefficient using a C. So that location, C, if you want to call it that, has to be between 1 and a little bit less than 10. So to write your scientific notation again, if you are moving to the left, which means you have a really big number, that's when you're adding your exponents. If you're moving to the right, that means you have a really small number and you're really subtracting your exponents, which is really going to give you a negative exponent. So again, the way I like to remember it really isn't the left or right movement. I like to think about, is it a large number? If so, that's a positive exponent. And if it's a small number, then it's going to be a negative exponent. And you're going to remember that a small number actually starts with 0 point. So if it's like 0.003, that's considered a small number. But if it's like 330,000, 3 billion, then that's obviously a large number. All right, example 1, express the number in scientific notation. If you notice right away, you definitely have a large number. So this is going to remind us that it is going to be a positive exponent. We're going to locate our decimal point first. We're then going to move it however many times that we need to. So again, the movement right now on your notes, please go ahead and put those little bumps there. You can all count, but we're practicing moving correctly. So we have a total of 6 so far there. We're going to move it one more. Oh, that would just be 68.7. It has to be between 1 and 10 something. That was my son Hunter. He's not reminded or not listening that, hey, I need to work. He's getting something. All right, so right there, if we stop between the 6 and the 8, I would be able to write my scientific notation as 6.87. But again, if you need to, you could go back and count. So you get a group of 3, 3, another group of 3, 6, 7, 8. So again, that would be positive 8 spaces, which would be an exponent of positive 8. It's a large number. So we have our standard form number written as scientific notation number. We got another large number there. Again, we consider anything a large number right now, anything that doesn't start with a 0. So we look at the decimal point, we move it a bunch of times. Again, a lot of students can get this if they remember where to stop, and that's the key point. Because again, you could all count, you can move the little decimal point. You got to stop again when it's between 1 and almost 10. It has to be a little bit less than 10, so like 9.999. If I stop there, it'd be 77. Now, the nice thing is on the big numbers, students usually rock it. They know exactly what to do. You just move it, count it, write it. It's when it's the small numbers that students struggle. Move it 5 spaces, positive exponent because it's a large number. All right, so let's talk about the small numbers. The small numbers, again, are the ones that start with 0 point something. Notice where the decimal is located. It's already given to you. We need to move it to the appropriate spot. So as you're doing those little bumps, that's just a reminder of, do I stop or do I keep going? So if I stop too early again, it's going to start with a 0. Unfortunately, this is where a lot of students stop. Remember, when you're moving, your decimal point has to be between 1 and almost 10. So if I stop here at 3, in between the 3 and the 2, that is definitely going to give me a 3.25. And then I moved it 5 spaces, small number, negative exponent. So I've got 3.25 times 10 to the negative 5th power. All right, let's try another small one. Notice how it starts with a 0 point. That's how we know it's a small number, which is going to require a negative exponent. So let's see here. Nope. Nope. Yeah, stop there. So we're going to go ahead and write it as 9.02. We only moved it 3 spaces. Again, if you struggle with the knowing if it's a positive 3 or a negative 3, my way I do it, again, is if it's a small number, it's going to be negative 3. Let's see if Lulu helps. Lulu, come. Lulu, up. Lulu, up. No. Lulu, come. Lulu will help us remember. Lulu, up. Up. Come on, big dog. Come on, buddy. All right, let's see if you can get in the camera. Hi, people. Scientific notation is awesome. She's my therapy dog. We love her. All right. Oh, go somewhere else. All right. Going the other direction, meaning if you have a scientific notation and you need to write it in standard notation, which means a normal number, you need to remember, looking at the exponent, is it going to be a big number or a small number? Remember, a positive exponent, like we have here, is going to represent a large number. So like millions, billions, things like that. Excuse me. So the easiest way for me to do it is to write the 3.201 again, but I'm going to put some additional zeros at the back. How many zeros? I don't know. Let's count. We need to move it 6 spaces. So let's see. 1, 2, 3. If I've only moved 3 spaces and my exponent is a 6, that means I need to move 3 additional spaces. But in order to do that, I need to put 3 additional zeros. So in other words, if it started at 3 point and I move it 6 spaces, the decimal point is now at the back. Hopefully you remember your comma placements from elementary school. And you're going to know that this is a big number starting in your 3 million range. So if you put your commas in the correct spot, it would be read as 3,201,000. Remember, there's no and word there because the and word represents the decimal point. So again, big number is a positive exponent. This one right here, it has a negative exponent, which tells me it is a small number. That means the zeros are not going to be at the back like the letter A. They'll actually be in the front. So when I write it, I'm going to leave some space in the front. I need to move my decimal point 5 total spaces. So that means if I move it just once, I need to put some additional zeros. Now here's the trick though. Move it 1, 2, 3, 4 more times. Because remember, 1, I moved it, it's in front of the 8, 4 more times, which means I need 4 zeros. But if you notice, if I just leave it at the 4 zeros, I don't see my decimal point, which is why I need to put an additional 0 that goes at the very beginning. So right there, I'm going to point that out. You've got 0 point, and then you've got 1, 2, 3, 4 zeros from when I moved my decimal point. All those little bumps there. So the 0 at the very front, please write that. Again, in math, and especially in some of your sciences, we want that 0 in the front, 0 point, and then again, however many zeros from when you moved your decimal point. All right, give you a moment to see if you can try this one. So I'm going to put a timer on my phone here for 30 seconds, which means you should all be able to do that. Okay, I'm stalling right now. Write it down. Got 30 seconds to write it as a standard form number. As I awkwardly stare at the camera. 15 more seconds. Where are you putting the zeros in? At the back or in the front? That's the question you're asking yourself. How many times do I need to move the decimal point? 4, 3, 2, 1. All right. You should know that you're going to move it 5 places because the exponent is 5. It's a big number because it's a positive 5 for the exponent, which means you're going to put the zeros at the back. How many zeros do you need to put? Well, let's see. I'm going to move it once, twice. I need to move it a total of 5 times. 3, 4, 5. To get your blank spots, you need triple zeros. If you can write it correctly, it's not going to be in the millions. It's going to be read as 649,000. Remember, don't say 649,000. That would be an incorrect statement. All right, big number. Now you try a small number. Give you 30 seconds. Go. Where are you going to put your extra zeros? At the back, at the front. How many times are you going to move your decimal? 10 more seconds. Sorry for the cricket in the background. 3, 2, 1. All right. Since it's a negative exponent, it's going to be a really small number, which means the zeros are in the front. We're going to move our exponent, or sorry, we're going to move our decimal point a total of 3 times. 1. Now I'm going to count the zeros. 2, 3. So it means I need 2 additional zeros in front of the 1. We're going to remember the example that I helped you with. We need 1 more 0 at the very front, because it's got to be a 0 point. And then I put the double zeros, 1, 8. So a really small number. Think about a microscope for the small number. Think of a telescope having to look into space for the large numbers. That was it. All right. Our awesome team is going to pause the video and pass out the worksheets. Go ahead and pause the video and pass out the worksheets. All right, welcome back. Hopefully that was enough time. You paused it, passed out the worksheet. Going to spend a little bit of time helping you with some of the actual homework problems. Let me see if I can get this up and running. All right, so your worksheet here, you've got some really basic ones. It says write the given number in scientific notation. All you got to do is move your decimal point. Right away, you should notice, okay, letter A, that's a really big number, so that's a positive exponent. But letter E, that's a really small number, negative exponent. Notice how it was always like times 10. And I still don't know why they use the X for scientific notation instead of a dot. What you're going to learn actually in high school, I just learned this with my son recently, is there is a special button on your calculator that you could possibly use it to help you out. If you don't do times 10 on the calculator, just special button. Then number 2, it says write the given number in standard notation. So this is the one that we just practiced going backwards. So you have to remember, okay, is it a big number because it's a positive exponent, or is it a small number for a negative exponent? So refer to your notes. All right, number 3, it says fill in the blank. So you're going to go ahead and rewrite them. And if you notice, they have a similar start. It's really the exponents. Okay, in letter B, 1 is done for you. So let's go ahead and do letter A real quick. Let me zoom in. All right, so let's see. Hopefully we've got some room to write. Got my writing tablet. I noticed that they are both small numbers, so I can't make my decision on greater than or less than. I know it's not going to be equal, though, because they don't have the same exponent. So let's see. Okay, 5.48. And it says I need to move it 4 spaces, so I'm going to put some zeros in the front. So let's see, 1, 2, 3, 4. So that's 0, 0, 0. So I'm going to write it as 0 point. Then I put a triple 0, 5, 4, 8. All right, this one here, similar style, 5.4, but this time I'm only moving it 3 spaces. So maybe that's a hint to you. 1, and I'm going to move it up 2, 3. So that means double zeros, decimal points there. So it's really 0.0054. Now, sometimes you could actually make your decision based off of money, meaning like it might be in the cents. This one's a little bit too small for that. But essentially, what you're going to learn through your section above is the more zeros in the front, the smaller the number it is. The more zeros at the back for the big numbers, the larger that number is. So if I use my inequality correctly, we're going to say less than, because 0.000548 is less than 0.0054. Because again, more zeros at the front means it's smaller, so less than. All right, over here on this section for number 4, all these different letters, it says write or order the numbers from least to greatest. Now, some people will be able to tell, especially from that previous one, that, okay, -4 is going to be the smallest number. Because again, that would have the most zeros at the front. So I can actually just go 5.01 times 10 to the -4th. That's the smallest. Then we're going to have the -3 exponent. The -2 would technically be the larger numbers, but if you notice there are 2 of them. So which one would be greater, the 5.2 or 5.6? Now, if you're a little unsure, you could always bring it over here to the side. And the 5.2, it says move it 2 spaces to the left because it's small. So let's see. Oops. 1, 2. So that would be 0.052. And then this one right here, sorry, 5.6. Here's that extra work. Still moving it 2 spaces. 1, 2. So that would be 0.056. When it's written in standard form, some students will be like, oh yeah, of course, this is like a little bit more than 5 cents. This is a little bit more than 5 cents as well, but this one is bigger because the 6 is greater than the 2. So we're going to use the original number, which is 5.2 times 10 to the negative second power, and then our 5.6 times 10 to the negative second power. Some students, they don't even have to do that extra little writing to the side. They can just look at it. So for example, this one right here, well, negative 10 is going to be the smallest. Oh, I'm helping you out too much. Then negative 8, then negative 7, and negative 6. So that one is just like, boom, quick order. So least to greatest. Remember, that's the smallest number to the largest number. Let's see, anything else on the front that we want to look at? All right, this one right here, it says, oh, solve each problem, convert final answers to scientific notation. So what you're going to do right now, because we haven't taught you all the other work, is you're going to change this into standard form. So this is a small number, this is a small number, and then you're actually going to add them together. But then your final answer, you're going to write it in scientific notation, just like you did at the top section. So if you have a really big number, remember it has a positive exponent. If it's a really small number, starting with 0 point, you're going to have a negative exponent. Right here, it says in 2010, there were about 4 times 10 to the 7th people living in California and 1 times 10 to the 6th in Rhode Island. How many times larger? Whenever you see that phrase, how many times larger, it means division. So remember, you're going to write this number in standard form. You're going to divide it. It's going to be easier than you think. And then your answer, let's say you get like 40,000 or even 4,000, then you're going to change it back into scientific notation. Later on this week, we will teach you how to actually do the work when it's in standard form. So when it's in scientific notation form. All right, looking at the back section, solve by graphing. Yeah, let's do one real quick. Let's do number 7. Number 7 and number 6 are actually the same type. So let's just say M1 is 1/2 and B1 is 0, 2. Right, so we're going to go ahead and use one color to represent that. 0, 2 from the origin, remember, is down 1, 2. Remember, this stuff is going to be on your quiz, always spiral review on quizzes, and it will be on your final. All right, we go up 1, right 1, 2. Up 1, right 1, 2. Let me zoom in. Up 1, right 1, 2. You can always do the backwards counting. Down 1, left 2. Down 1, left 2. All right, then we make our line. And we make our arrows real quick. Remember, we are trying to find the point of intersection. That's our goal. All right, different color, M2, meaning the second slope is in front of the x, so it's -1, which is really -1/1. And our second y-intercept is 0, -1. Sorry, it's getting a little snug there. All right. Oh my goodness, Mr. Murillo, can you believe it? Look at, I even said here 0, 2, but I was in a rush, so I went down to. Whoa. Whew, glad I caught that. Let's move them up. I knew that. I can't believe you made that mistake. All right. Whew. Well, I'm glad I found that mistake before I try to find you the point of intersection. Oops. Let's erase those. That would have been bad. Again, if you're going too fast, you're going to make mistakes. All right, back to it now. 0, -1 is right there. Okay. Down 1, right 1. Down 1, right. Let me see, did I do it correctly? 0, -1, down 1, down 1, right. Okay, backwards. Oh, yeah, right there. Some of you might stop. Others might just keep going. Found my point of intersection. So remember, what we're going to ask you to do is next to your graph is identify the point of intersection, which is left 1, 2, which is a negative 2, and then up 1, which is a positive 1. Excellent. All right. Let me see what happened. There we go. Whew. Sorry about that little mistake. That's why we do our math in pencil. All right, so you've got graphing, solving by the system. We've got substitution. We'll do one of those. Elimination. Let's just briefly talk about this. We've done this one kind of recently. And all you have to do is identify x and y. And then you're going to do quick substitution where x goes there, y goes there. You're really going to split it up. And remember, to be a solution, you have to get two true statements, like 5 equals 5 or 3 equals 3. That's a true statement. So those ones should be really quick for you. But let's talk about our substitution and elimination. Substitution, remember you do that whenever you have an equation that has an isolated variable. So y is equal to, and again, we've got x plus 4. Again, Mr. Daniels and I were very impressed with your first attempt in learning your substitution method. It kind of shocked us because a lot of students, previous years, when it's y equals, they would draw it to the x because they see the x. But us, being responsible students, would put it at the y because y equals. All right, this gives us a new equation. 3x subtract 2 multiplied by, well, whatever we circle, so I'm going to write x plus 4, and that's going to be equal to negative 7. So the 3x stays the same. I use my distributive property. And then we'll solve our equation. 3x subtract 2x, thankfully that's just a nice x. We're going to add 8. So x is going to be equal to positive 1. And the nice thing is, most of you can just look at that, but if you need to, you'd bring it down here and say, okay, if x is positive 1, then we know 1 plus 4 is 5. Remember your answer, 1, 5. A lot of you did very, very well with substitution. All right, elimination method. Remember, for elimination method, we would like same digit, opposite sign. The good news is the x's and the y's are the same level of difficulty because it's just a 3 and a 2. But I do like x's because they're already opposite. So it means I'm going to put brackets around both. We're going to think about what we want to multiply. So if I want to eliminate the x's, I can have them become 6's. So that means this is a 3 and this is a 2. I'll bring it down here. Remember, it's just your distributive property. 3 times negative 2x is 6x. 3 times 3y is 9y. And 3 multiplied by negative 15 is negative 45. 2 times 3x is 6x. Notice for the x's, we now have the same digit opposite sign that we needed. 2 times 2y is 4y. And 2 multiplied by negative 23 is negative 46. All right, x's eliminate. I've got 13y is equal to, they're both negative, so I'm going to keep them negative. And I'm going to add them up. Let's see, 5 plus 6 is 11, little 1 there, 91. So if I divide both sides by 13, I'm going to find out that y is equal to negative 7. And then from here, you pick which one you want to do to find x. It doesn't really matter. I'm actually going to take the bottom one because it has a little bit more positives. That's a little bit easier for me. So I'm going to say 3x plus 2 multiplied by y, which I think is negative 7, and equals to negative 23. 3x stays the same. 2 times negative 7 is negative 14. If I add 14 to both sides, 3x is equal to, what's that going to be? It's definitely negative. Some of you might actually need to come over and do the subtraction. And again, there's no shame in that. Borrow from the 2, make it a 1. 13 subtract 4 is a 9. Oh, so this will work out nice. So x is going to be negative 3. So remember our answer in the form x and then y. All right, so we did a bunch together. You're going to go ahead and do the best that you can to finish it up and upload it as always. I hope to be with you guys tomorrow. But again, if jury duty keeps me around, we'll see. All right, be awesome, guys.